A very good morning, students. In our today's class, we will be discussing about the task of a field geologist in an engineering project. Actually, the task of a field geologist change with refers to the nature and the objective of the project. Say, for example, in our previous class, we had discussed about the task of a field geologist in a mining project. And if you compare these both the things, that is the mining project and engineering project, you will find out the differs in task. Actually, because the nature of the task in mining project is a geologist have to look for a mineral deposit and you have to take it out. And for engineering project, the geologist have to look for a best site for the construction. So the nature differs as well as the objective as well as the task of a geologist will differ. The very first task of a geologist in engineering project is to provide geological information and interpretation for the engineering design. Let us take the example from a dam site. This is a dam site in which this is a gravity dam. So the actual mass of the dam is passed to the basement rock, and if the basement rock is not hard, then this structure will not be stable. In such a case, what happens, they will change the design of the dam from a gravity dam to the arch dam. In arch dam, what happens, the mass is transferred to the abutment rocks, that is the side rocks of the valley. So you can see from this that the engineering design is totally depend on the rock strength on the site of the dam. Okay, and the next thing is to identify, map cross section and to evaluate potential seismic and other geological geomorphological conditions and or hazards. Actually, what happens, you are constructing such a large structure, artificial structure in a natural environment. Definitely this artificial structure will interact, that is react with the natural environment, and there may be some disturbance, like the disturbance could be such a big, like the Three Gorges Dam of China actually reduces the rotational speed of earth by 0.06 microseconds, which has been expressed by NASA. Or they can also reactivate a faulted region, or they may lose the water due to the structure. See, the first example is this one. This is a faulted region where the engineering engineers doesn't consider the fault, and what happens after constructing such a gravity dam, the weight, that is the mass of the dam, is passed to the basement rock, and that leads to the reactivation of this fault. And due to the reaction of this fault, what happens, the fault, there may be a origin of earthquake, and this may disturbs the dam and tend to collapse. And this is the second example where there is a fault and a dam is constructed on an axial plane, and what happens, the beds are dipping towards the downstream. So whatever the water that is stored here will percolate down here and moves towards downstream. So the actual cause of the dam which is constructed is not fulfilled, that is it cannot save any water here. So that is the geologists have to see the condition and hazard that is due to the construction of dam on that site, and also provide geological consultation during as well as after construction. Actually, due to the construction of such a big site, what happens, the speed of the river has been dramatically reduced in this region, and all of a sudden when it is released on the downstream side, what happens, the speed is much increased, and such a change in the velocity of the river may leads to deposition in this region and a sudden erosion in this region, and the geologists have to take care of such a thing and do some remedial measures, unless it will be a very big disturbance to the dam as well as leads to collapse of the dam. A geologist have to evaluate the material resource, as the dam needs a large amount of resource for the construction. So a geologist have to look for the places where someone can mine out the material and use it for the construction. The geologists have to plan and evaluate remediation and restoration program for hazard mitigation and land restoration, because construction of such a big dam will lead to the flooding of the upstream region, and such a flooding may definitely disturb the people who are living on those regions. So they have to be shifted to some safer region, and such a thing has to be planned by the geologist. Then define and establish site selection and evaluation criteria. Let us take these three examples. This is the initial stage, that is the youth stage of a river, and this will be the matured, and this will be the old stage. If they are constructing a dam on the youth stage, what happens? There may be not sufficient water to be stored because it is the initial stage where the streamlets join to form a river. And if it is constructed on a old stage, what happens? The river is doesn't have sufficient water. As well, the river may consist large amount of sediments. So they have to select such a location where it is in mature stage. Not only that, the valley should be narrow, because if it is a broad valley, then they need much amount of construction material to construct a dam over here. Whereas in this location the valley is quite narrow than this, so the material required for construction is much lesser. So the geologists have to establish the site for the construction of dam, as an example. Not only that, the laboratory testing of the earth materials is also done by the geologist. The rocks has to be taken from the field and have to be tested in the lab, and to express it and to find out whether the rock can hold this amount of pressure which is given to it by the dam. Okay, so all such things have been conducted by a geologist in a engineering project, and this has been given by the National Association of State Board of Geology, that is ASBO, from which I had taken these things. Thank you.